Okay, so now that you feel really comfortable with solving for x, finding the solutions, writing quadratics, multiplying polynomials, factoring polynomials, yada, 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 we're going to do a couple more things with our quadratics. First thing we're going to do is we're going to have a vertex and a point, and we're going to write the quadratic equation, or we're going to write the equation for the quadratic. Okay. So the first thing we need to know is, and we've already seen this, the vertex form is y equals a x minus h, x minus h, x minus h, x minus h. Hey, how's it going out there? Okay, x minus h squared plus k. H and k are the vertex. Okay. A is the same as the A in standard form. So when you're looking at that A, it's the same A as ax squared. Okay, so let's go ahead and look at number 1. The first thing that we noticed about the general form above is that A equals 6, and then we know H equals 5, K equals -1. So the vertex is going to be 5, -1. The vertex is a ordered pair. So if you've been writing just one number, it's been wrong. And you'll notice from our vertex form, the x value is the opposite sign and the y value is the same sign. The axis of symmetry is a line. So if you've been writing an ordered pair for the axis or the line of symmetry, it's been incorrect. It's a line and it always starts with x equals and it goes through the vertex, so it's x equals 5. We tell if the parabola is a minimum or a maximum by looking at A. If A is positive, it's a smile and it has a min. If A is negative, it has a frown and it has a max. So based on what we've done so far, since our A equals 6, we know we have a minimum because it's a smile. So based on having a minimum, what do we know? We know that we have a minimum. We know that the domain is always all real numbers. I know that the range is going to be, since I have a minimum, it's going to be greater than or equal to, and whatever my vertex is the lowest point. So y is greater than or equal to -1. Okay, now we're going to take a point and a vertex, and we're going to write the equation. So I know that h equals -1, k equals -7, and I'm going to use this point right here, so I'm going to have x equals 5 and y equals 2. So h is -1, that means in my equation it's going to be plus because it's minus a negative. I don't have a, so the first thing I'm doing is I'm solving for a. So I have 2 equals a times 5 minus a -1, so it's going to be +1 squared minus 7. 2 equals a 6 squared minus 7. 2 equals 36a minus 7. I'm going to add 7 to both sides. So I have 9 equals 36a. Divide both sides by 36. And I have a equals 1/4 or 0.25. I'm going to substitute that back into my original equation. And so I end up with y equals 1/4 x plus 1 squared minus 7. So here's my vertex form. Once I have vertex form, I can just work it all out, multiply everything out, and I'll end up with ax squared plus bx plus c. So first thing I'm going to do is I'm going to multiply x plus 1 times x plus 1, which is not x squared plus 1. I have x squared plus 2x plus 1 minus 7. So I need to multiply everything by 1/4 before I do anything else. So I have 1/4 x squared plus 1/2 x plus 1/4 minus 7. So I have 1/4 x squared plus 1/2 x minus 6 3/4. I can multiply everything times 4, which would give me, if I multiply everything times 4, I end up with y equals x squared plus 2x minus 24, 27 times 4 divided by 4 is 27. There you go. Both of these are correct. One just looks prettier than the other one. But if I graphed them, they would make the exact same equation. All right, number 4. Same thing again. Here's my h, here's my k, here's my x, and here's my y. So I have y equals a times x minus h squared plus k. So I have no, not y. I have -3 equals a times 1 minus 3 squared plus 5. -3 equals 1 minus 3 is -2. -2 squared is 4. 4a plus 5. Take 5 away from both sides. I end up with -8 equals 4a divided by 4. A equals -2. So my vertex form is y equals -2 times x minus 3 squared plus 5. Here's my vertex form. So to change it to standard form, I'm just going to multiply everything out. So I end up with y equals -2 times x squared minus 6x plus 9 plus 5. Totally didn't have enough room. Y equals -2x squared. There's my a. -2 times -6 is plus 12x minus 18 plus 5, which is minus 13. So I'm going to go ahead and change that to a 13 because -18 plus 5 is 13. And I'm sticking to it. Okay, so here's my 2 different forms. All right, last one I'm going to do, and then I'm going to set you loose to do the rest of them by yourself. 5, 6, 7, 8. Okay, so I have h equals 4, k equals -2, y equals -3, x equals 3. I don't know why I put them in that order, but -3 equals a times 4. Nope. 3 minus 4 squared minus 2, negative 3. 3 minus 4 is negative 1. Negative 1 squared is 1. So I have a minus 2. Add 2 to both sides. A equals negative 1. Y equals negative 1 times x minus 4 squared minus 2. And then I'm going to work that all the way out, and I'm going to end up with y equals negative 1 times x squared minus 8x plus 16 minus 2. Y equals negative x squared plus 8x minus 16 minus 2 makes minus 18. I guess that's my phone. I don't know where it is. Okay. That's a really rotten 18, but it's an 18 nonetheless. Okay, 18. Okay, I'm going to let you do 6 through 6, 7, and 8. So I want you to work it out. I will give you the answers. And tomorrow, when I see you, if I see that you actually did work, I will give you something special, maybe bonus points. So here's the answer to number 6, which is not good enough to get something special tomorrow. Y equals negative 1/2 x minus 3 squared plus 2, and y equals negative 1/2 x squared plus 3x minus 2.5. Number 7. Oh, number 7 was interesting because I ended up with 2x squared minus 5 because when my vertex is 0, that means my x becomes 0. So that whole multiplying out my quadratic kind of went away. So this is actually for both. I would put this down as my answer. And then number 8, hope you work these out. I have y equals 1/2 x plus 10 squared. Y equals 1/2 x squared plus 10x plus 50. All right, make sure you put a note right there if you have any questions, because I am not going to work those out for you, but I will if you have questions. But I need to see work so I can give you extra points. And I'm also not going to do the whole similarities and differences. The most important one I hope you saw was that the A value is the same. Maybe you found something else. I hope so. Okay, let's do number 10. They gave me the vertex. They gave me an x and a y value. So I'm going to work that out. By negative 4 equals a times negative 1 minus 4 squared minus 9. Negative 4 equals a times negative 4 times negative 1 minus 4 is negative 5 squared. So I have negative 4 equals 25. A minus 9, add 9 to both sides. I end up with 5 equals 25a. I divide by 25. And I end up with a equals 1/5. And then I go, ooh, wait a minute, none of those have fifths in it. So I am going to say that y equals 1/5 times x minus 4 squared minus 9. And I'm going to multiply everything times 5. So I end up with y equals x minus 4 squared minus 45. Y equals x squared minus 8x plus 16 minus 45. It's not C or D because I have minus 8x. So I have 16 minus 45, which makes negative minus 29. Okay, number 11, I kind of had to do some work because I had to think about this. Because my first thought is, oh, of course there is a value. But if I put 5 in for y, let's see what I ended up doing. I said, well, okay, so let's say 5 equals negative 2 times x minus 1 squared plus 4. So 5 equals negative 2 times x squared minus 2x plus 1. Sometime ask me how I do that so fast. So I end up with 5 equals negative 2x squared plus 4x minus 2 plus 4. I'm going to add minus 5 to both sides. 0 equals negative 2x squared plus 4x. I think I didn't do all this work a minute ago. 7 minus 3. I did not do all that work. I did not. Well, I graphed it for sure, and it didn't reach the exact, or it didn't, yeah. The answer is no. I did not do all that work. What did I do a minute ago? Because basically, I have to have a solution to that. And if I have my product is 6 and my sum is 4, there are no magic numbers, which doesn't mean that there's not a solution. Okay, we're just going to leave that like that for now. We'll talk about it tomorrow. Because this ended up being way longer than I thought I wanted it to be. Okay, for this one I used 3, 1, and I used 2, 3. So h equals 3, k equals 1, x equals 2, y equals 3. 3 equals a times 2 minus 3 squared plus 1. 3 equals 2 minus 3 is negative 1. Squared is just a plus 1. Take 1 away from both sides. A equals 2, which means it has to be D. Okay. Saeed kicked the soccer ball. Okay, so here's what I know when Saeed kicked the ball. That at 12, it's 0. And at 6, it's 36. So I used X, Y, no I didn't. I used H, K, X, and Y. So 0 equals A times 12 minus 6 squared plus 36. 0 equals 12 minus 6 is 6. Squared is 36. A plus 36. Subtract 36 from both sides. I end up with 36. negative 36 equals 36a. I divide by 36. I end up with a equals -1. So I have a -1 first of all. So it's got to be b, because I don't really have to solve it if I have y equals -1 times x minus 6 squared plus 36. Y equals -1 times x squared minus 12x plus 36 plus 36, -1, negative x squared plus 12x minus 36 plus 36. So those cancel out. So I have x squared minus 12x, negative x squared I thought it was b, but I had my sign wrong. So it's not C and it's not D. Oh, no. Okay, we'll talk about that one too. Okay, I'll see you tomorrow. We'll finish.